Here are 5 radical questions you are almost guaranteed to see on your final. Let's go. Okay, we are simplifying the -2 fourth root of 96 and a +2 fourth root of 96. As complicated as this whole thing looks, those two are still just going to cancel out. So now I need to deal with this fourth root of 405. So I'm looking for a number multiplied times itself 4 times that might go into this 405, unless 405 is one of them. Now your fourth roots, let's just make a little list. 1 to the 4th power is 1. 2 to the 4th power is 16. 3 to the 4th power is 81. And 4 to the 4th power is 256. 81 times 5 is 405. So when I break this up again, I'm going to have -2 in the front, and then I'm going to have the fourth root of 81 times the fourth root of 5, and then we end up with the fourth root of 81 is 3. So it's -2 times 3 times the fourth root of 5, and we end up with -6 fourth root of 5. Put a box on it. We are done. I'm going to take 3 root 2 times 2 root 5. 3 times 2 is 6. 2 times 5 is 10. Then I'm going to take the 3 root 2 times -5 root 5. -15 root 10. 3 times 2 is 6. 5 times 5 is 25. 3 root 5 times -5 root 5. -15 root 25. Root 25 is just the number 5. So this is just 6 times 5. And this is 15 times 5. And these two have the same radicals, so I can combine those. 6 minus 15 is -9 root 10. Plus 30 minus 75. And there we go. We are done. Put a box on it. Let's simplify this. Now, this is a little bit different, and you have to do something here called the conjugate. But if you forget the word, remember this. From Algebra 1, if you multiply a plus b times a minus b, you get a squared minus b squared, the difference of 2 squares. We're going to use this to manipulate this denominator to lose that radical. So this is 3 plus the square root of 2n cubed. Let's take the top and the bottom times 3 minus the square root of 2n cubed, which is like this a plus b, a minus b thing. Now, whatever you do to the bottom, you have to do to the top. Multiplying straight across, we end up the numerators multiplied together. But then what you have on the bottom is the 3ab squared minus this whole radical thing squared. And when you square a square root, that square root just cancels out, and you end up with 9 minus 2n cubed. You get whatever was on the inside. Now on the top, I multiplied that out with distributive property. Then I look at this numerator. You see this n cubed that's underneath the square root sign? I can pull an n out of there. So you end up with 12 minus 4n square root 2n over 9 minus 2n cubed. There is nothing else I can factor out of there, even though there's n's all over the place. This 12 doesn't have an n factor, and the 9 doesn't have an n factor. So the best we can do is put a box on it. That was question 3. If you are cramming last minute, this is part of a video series covering the entire Algebra 2 final exam. The full playlist is in the description. Next question. Write in exponential form. The square root of a is the same thing as a to the 1/2. The cube root of a is a to the 1/3. The fourth root of a is a to the 1/4. You guys see the pattern. Whatever the number is here goes on the denominator. The exponent on the a underneath would be the top, and since I just used a's here, that's just an exponent of 1. I'm just going to rewrite what's on the inside first, which would be 10x to the 1/3 power. That is the cube root of 10x, and that whole thing is being squared. You are taking a power to a power, and there you go. So it's 10x to the 2/3, and that is the same thing in exponential form. I want that radical to be by itself, and then I'm squaring both sides. You're going to get 14 minus x on this side, and over here, if you square x minus 8, you get the trinomial x squared minus 16x plus 64. I need to get a 0. I'm just going to subtract 14x from both sides, and then I'm going to add the x, and I end up with a 0 equals x squared minus 15x plus 50. This is something I can factor. So I did. If x minus 10 equals 0, that means x equaled 10. And if x minus 5 equals 0, that means x equals 5. So this is where you're checking for extraneous solutions. Is one of these numbers going to work, or are they both going to be bad? Let's see. So I'm sticking the 10 in first. Is 8 plus the square root of 14 minus 10 equal to 10? Well, 14 minus 10 is 4. The square root of 4 is 2, and 8 plus 2 is 10. So yeah, that one works. Let's plug the 5 in. I get 14 minus 5, that's 9. The square root of 9 is 3. 8 plus 3 does not equal 5, and that's what they mean by extraneous solution. When you're solving quadratics, you can get one that's not going to work. So you only have one solution here, and that is x equals 10. 5 radical questions reviewed and done. You're one step closer to passing your exam. If you need to master exponentials and logs next, that video is waiting for you right here. Now go crush your final.